Hey there, this is Ryan Jones from Serverless Guru. I wanted to make a quick video. I actually filmed about 30 minutes going through this video, which is about 7.5 minutes. But I lost that video, so therefore I cannot show that to you. Basically, what ended up happening is that I use a tool called loom.com, and it recorded or showed it was recording for 30 minutes. What actually happened, it's not Loom's fault. I think what I actually did is I hit pause and then I talked for another 29 minutes and 30 seconds and then hit end on it and I never actually started the video. So not good, but what I can say is we'll do a quick overview of this video. That way I don't have to completely redo it because that would be very brutal. So this one's going to be a lot shorter probably. So let's just go through. I'm just going to recap some of the stuff that got talked about. I'll make this full screen here. So one thing that we did talk about here is that there is something called Sam Deploy dash dash guided there. And so this is the AWS Sam framework, and same as the serverless framework. They all have CLIs that allow you to actually use them to make the deployments faster. So Sam Deploy dash dash guided appears to be a newer feature, and it allows you to get a GUI in the terminal. So down here you can see stack name is equal to Sam app, and then James is actually going to enter some of that stuff in. So that's really cool, and it's a nice way to add a little bit of extra functionality to make it more obvious what is happening to the end user, right? So the more, it's nice to have things that work magically, but it's also nice for people to, understand how that's happening. So that's good. And then as we continue to move through this video, you can see there that he enters a few more values in here and then hits enter. You can see down here that there is a couple of values. One of them is the deployment S3 bucket. Another one here is the capability IAM. So whenever you deploy a CloudFormation stack that has an IAM role inside of it, you need this capability here. You typically don't need to think about it when you use AWS SAM or you use a serverless framework. But if you write your own CloudFormation stacks, or you try, as I did for another client, try to rebuild a serverless framework or an AWS SAM equivalent that had its own custom functionality for that internal company, which I would, it's actually an interesting project, but it's a very difficult project that requires yeah, a lot of buy-in from people because basically imagine this. So you're going to change how people make these deployments. So you need a dedicated team of, let's say cloud acceleration or something like that, whatever the team wants to call themselves, that actually builds that tool, maintains that tool, keeps it up to date at the same level as the serverless framework or AWS SAM, has all the newest updates. So somebody needs to understand that whole system. They need to make updates to it. They need to maintain it. All the other people that work at the company, all the different teams, they'll use that, they'll standardize it. That's amazing. But then there's always going to be things that are being tossed back over the wall, things that are not working properly, and it can easily get out of control. So with that being said, when you build a platform like that, when you build your own serverless framework or AWS SAM, you're going to have to worry about things like this capability IAM here, and you'll see that pop up if you don't actually include. If you try to make a CloudFormation deployment, doesn't have that setting there, and you're using the AWS SDK to deploy that CloudFormation stack, then it's not going to work properly. So cool. Here you can see that James is going through the AWS SAM template. In the last video that we covered on the Serverless Guru YouTube channel, kind of reviewing all this stuff, he showed the S3 bucket and also Lambda function. Now we actually have an S3 bucket, a Lambda function, and a DynamoDB table. And so here you can see we have a DynamoDB table specified on line 20 through 29. And you can see the billing mode here is pay per request. You can actually have read and write capacity, where you basically have these two dials. But pay per request is going to allow you to scale up a lot better and scale down better because there's no minimum. So you go from 0 to 100 and then back to 0 versus with the versus the read and write capacity where you set a read, let's say 5, and you set a write at 5. So you have 5 read and 5 write capacity, and then you can do the calculations on how to actually figure out how much you need. But the problem with that is just like trying to figure out what server instance type do you need, right? Like how big of a server do you need? How much memory do you need? And those things are very hard questions. And so the pay per request is a very easy way to know, okay, as I get more requests, then my database is going to scale up with me. I'm not going to get into situations where I set 5 read and 5 write, but now I'm operating at 10 read, 10 write, and now my database starts getting throttled. There is actually auto scaling with DynamoDB, but the auto scaling it may be better now, but it used to take like 10 to 15 minutes to actually scale up the read and write capacity. So if you get hit with 1 million requests because your thing went viral and before you're only getting 1,000, it's going to be 10 minutes before it actually scales up to match that. And that means, at least in the old system with DynamoDB, you'd be getting throttled for about 10 minutes before it finally caught up to the traffic. And obviously that's not good because, boom, your whole site's down, and that's not something that you want to happen. Down here, you can see on line 31, we have the import function. You can see on line 36, we have the Node.js runtime, and we have the memory size of 512. You can also see down towards the bottom, 46 through 56, you can see that he's adding an event here, which is going to trigger, the S3 bucket is going to trigger a Lambda function. And when is it going to trigger that Lambda function? If somebody does object created on line 51, and if the name is suffix, or sorry, so it's looking for, it's a rule of suffix, and the suffix needs to be .json. And so if there's a file with .json and it's being created inside of the bucket, then trigger the Lambda function. Okay, now moving to the Lambda function code that's actually going to be invoked. You can see here at the top, there's a few things. The first one here is we have the AWS SDK that's being imported. We have the document client on line 21. So when you say aws.dynamodb.document client, the document client is an extension of the DynamoDB library, and what it allows you to do is get more simplified APIs to interact with. So it's a wrapper over the DynamoDB library and all those methods, but it's just a little bit easier to work with. So instead of saying get item, having all this different structure where you have to specify the data type for DynamoDB specifically, like this is a string, this is an integer, all that stuff, you can use document client and you can just say get, and you can say put, and you can say delete, and you can say batch write. And those are a lot more simplified APIs where you can interact with them. And honestly, I wish that more of these AWS services with the SDK actually had these like wrapper libraries, because it makes it a lot easier to work with. However, the one asterisk being there is that because it's a wrapper over DynamoDB's existing methods, it's always going to have less functionality than the original. And so what that means is that if you need to do something outside of like get, write, delete, most people don't, so it's okay. But if you do need to, you might have to balance, do I use the document client? Okay, well, it's not supported, so I have to use the DynamoDB client. And that's pretty easy to understand, but when you get into code where maybe you're using the document client and you have to add functionality, like you need to get something like the metadata from the DynamoDB table, then you have to interact with the actual aws.dynamodb, not dynamodb.document client. Yeah, so that's one note there. One note there. On line 22, you can see the UUID v4 library is being imported here. This is going to allow us to create that random character string, which is going to be able to store as our ID for the DynamoDB table. And then here as well, we have a file inside of the folder structure here called s3.js. You can barely see it on my recording. But on line 23, you see that we're importing two different functions. One's called get s3 object. The other one is put s3 object. So now as we move down, you can see that we get into the exports.handler. On line 29, this is a really important line because we're doing a console.log with json.stringify event, and then null, and then 2. So what that means is that we're doing a console.log of the event, but the event is going to be a object. So we want to print that out as a string, which sounds weird, but this is actually how you want to do it when you're working with CloudWatch. And then you pass null, and then you pass 2. 2 is going to be the indentation. So you're going to say indent this by 2. So what it'll come back in CloudWatch is it'll actually come back as a indented object that's very easily able to be read and has indentation of 2. So you can make that 4 if you prefer that. So it's 2 here. And then what's really nice about printing out the event at the very top of your Lambda function is that if you have anything happen where, let's say, in my scenario, if you don't print out the event, bad things can happen. And I'll give one example of that. So when Lambda functions run, they run and they die, right? So it ran, it died. So if you don't have that event being printed out and you have some functionality happening, if something happens and maybe it works properly, right? Like maybe let's say that it actually does what it's supposed to do. That Lambda function invokes, it saves something in DynamoDB, and then it dies, right? It got the event, it took the event, it put things in DynamoDB, great. However, let's talk about a scenario here. Let's say that the client updated their front end code, but then the backend developers didn't update their backend code. And so the front end added an extra argument there. That extra argument said, let's say, transaction ID, right? So transaction ID is going to link together a whole bunch of different events. And so as with this distributed system happening, linking the events together is very important, right? So if you have a whole bunch of different, let's say you have an image that gets uploaded, you have some API with a result that happens, and you have some other thing that's happening in the background, and they're all related to each other. You want to track that, and for this scenario, we're going to say it's transaction ID. So what ended up happening with me is that we prepared for this demo at my company that I was at, and we had this whole team of people that were supporting it, and we basically worked on this application, the APIs, all these things for months, and then we finally had this big demo, and we had hundreds of people from around the company come use the demo, and what ended up happening was really bad. So the lead developer had code which added this field for the transaction ID. My code did not have that transaction ID. It didn't get stopped in source control. We didn't have all this these processes, all these things. It was very like, okay, we're ready to ship it, you know? And so I pushed that code and I kind of like leaned back like, all right, sweet, you know, we made it to the demo, everything's great. And then about 3 or 4 hours into it, the lead developer was like, hey, Ryan, so I'm not seeing the transaction ID here. And, you know, this is concerning because if we don't have the transaction ID, we can't link together all the things that people have been doing with the application. And if we can't link together the things that are being done with the application, then we don't really have anything to work off of for this entire demo that we just did, where we invited hundreds of people. And our project, as you know, is not really well funded. So this was supposed to be a proving ground, and we don't actually have the results of any of the stuff that's been done because they're just empty records. We don't know who they correlate to. We don't know what they were connected to inside of our system. And you know, regardless of should we have re-architected it in a different way, should we have had all these different barriers so that type of thing didn't happen? Yes, but we didn't have that. So this is the scenario. So how do you come back from this, right? Like what immediately, obviously my stomach dropped and I felt like ill because I was like, oh no, I'm about to lose my job because we had this demo, didn't store the value, all the data that we just got is you know pretty much meaningless because it's not correlated to anything. And so because we were showing different versions of, you know, applications and all that stuff, and so there's no way to understand what this data meant. So what we did is, because I made it a practice to print out the event on every single CloudWatch, or every single time that the Lambda function ran, I printed out the event. The event coming from the client had the transaction ID. My backend system, my backend Lambda function, did not store. It stored everything else except for the transaction ID. Now I write functions a little bit better now. I'll actually just import everything that I get from the event that's underneath the specific item value. I do that because DynamoDB is schemaless, and also because I hit this problem a long time ago, and it almost caused, you know, real pain. You know, I almost lost my job. So with this here, this transaction ID, I then went over to the CloudWatch log groups and I looped over all the CloudWatch log groups and pulled back that transaction ID out of that printed out event. And then from there, we were able to extract the different objects out of the CloudWatch log groups and then use that to then repopulate the database with the real data connected with the real transaction ID. And, you know, I didn't get, you know, crisis averted. I didn't get fired. So that was my war story there about line 29. It's a very small line, but it can be the line that's the most important line. Yeah. And then as we keep going in this file, basically I'll just give a high level overview. This function and this Lambda function is going to be invoked when somebody drops a file onto S3. It's then going to read that file. It's going to loop over it. It's going to create a whole bunch of arguments. which then, or sorry, a whole bunch of requests that then are going to be stored inside of DynamoDB. So as we get down here, you can see on line 38 through 41, you can see that they're doing get S3 object, it's coming back with the original text. And you can see there's a bucket and a key. And then we'll just keep going down here. Towards the bottom here on line 45, you can see upload JSON to DynamoDB. And let's just go and look at this. So the upload JSON to DynamoDB function is going to take data. So it's going to be the data from that S3 file. It's then going to set a batch size of 25. And then it's going to loop over all this data from that JSON file. And then down here on 79 through, let's say like 84, what you can see here is it's looping over the items here. So in each one of this JSON file, there's going to be like a nested object there. And so it's going to loop over those values. The first thing it's going to do though on line 80 through 84, the reason why it's doing this for loop here, where it says let key of object.keys item, and then it says on line 82 and 83, it's saying if the item key is equal to an empty string, then delete it. And so the reason why you want to delete the keys that have empty strings is because DynamoDB will throw an error if you try to store a value that has an empty string. And that's a very confusing problem. It's something that, it's something that everybody hits and everybody gets frustrated by. And the DynamoDB team, I guess it's a feature, not a bug, right? So it's like it causes problems every time. So because of that, this code has to have this extra loop for every single item that's inside of this JSON file to make sure that it doesn't have an empty string inside of it. Because if it does, then it's going to cause errors, and then those errors have to be caught somehow, and there's a whole bunch of downstream problems that take place. And depending on how nested your Lambda code is, you might have to catch that error a couple of times before you actually surface it, and looking to see, oh, was my JSON file on line 2038, did it have an empty string on that value? That's not usually the first thing that you look at. The error messages will give you that back, but like I said, you have to have proper error handling, and I'm speaking from experience here. A lot of times when you're building out these applications and you're starting to do this, and even if you're experienced, you may not have the error handling proper when you're at the proof of concept phase. So something to keep in mind. Make sure to check if you're passing empty strings to DynamoDB if it doesn't work. And you can see here on line 90 and 91, you can see that they're using, James is using the UUID v4 library. This is going to generate that random UUID for our ID, for the item. And then you can see the ..item, which is going to allow us to take that item object where we just deleted all the empty strings out of it, and it's going to then inject that into this object on line 88 called put request. And so there, we're going to then pass that to a function down here on line 101 called document_client.batchWrite. It's going to pass in params, which is this value here, line 87 through 94. And you can see here that it's also specifying the DynamoDB table name. So params and then .promise. So now this is a really interesting point to bring up. On line 101, where it says batch write params and then promise, it's actually going to do everything that a normal promise function would do. So normally what we would do with this document client.batchWrite is we would have a callback. So we would say params, comma, we'd have a callback there with like error and response. And then we would basically then have a wrapper over it that has return new promise. And then we would then run .batchWrite and then grab that callback. And if it's not an error, or if it is an error, reject it. If it's not an error, then resolve it. Then that'll finally come back. And then we can say await. So here we've taken, what was potentially an extra, 10, 15, 20 lines of code, and we've now made it a single line using async await pattern. So if you're not using async await, if you're using the AWS SDK and you're not adding .promise to the end of it, you should definitely be doing that. It's a very simplified way of writing these applications, and it's reduced the amount of code dramatically here. Okay, so with that, now we've kind of gotten through the Lambda code section here, and James is then going to go to the S3 bucket. He's going to upload a file here he's going to then, you can see here it's called locations small. When he uploads this file, it's then going to trigger the Lambda function, and all those events are then going, or all those nested JSON objects inside of that JSON file there, all of those objects are then going to be looped over, they're going to be cleaned up, and they're going to be injected into DynamoDB on a batch size of 25. And you can see that here. So you can see in the left-hand column, we have ID. You can see that that's the UUID v4 library there. And you can see address, name, position, and so on. And that's coming from the small city location .json file that James just uploaded. And now what James is going to do is actually going to upload a whole bunch of files. So this is what the data actually looks like. You can see position, name, address, phone, and all that. Now what he's going to do is go to the upload screen. He's then going to look back here, and there's more data flowing in. And I believe the next one here, he's going to upload a few of these files. Let me see if I can find it. Yeah, so he just did that there, and now there's a ton of data that just went into DynamoDB. And it actually happened very quick, so I'd recommend you watch this video as well. But basically what took place is the second that he dropped that file, it was able to create, I believe, like 200 batches of 25 each, and then actually go through and inject those into DynamoDB. And it's happening in real time. Like we're talking like less than 100 millisecond type stuff, like 10 milliseconds. So we're talking like, 10 milliseconds, 100 milliseconds. Let's round it up to 500 milliseconds after, half a second after he uploaded that JSON file, all of the records that were inside that JSON file were uploaded into DynamoDB, which is crazy because it had to invoke a Lambda function, had to do a whole bunch of loops, had to send that into doing a batch put request into DynamoDB. But in half a second, let's say to potentially a maximum of a second, it actually injected all that data in there. So here, we're looking at the CloudWatch console here. James is going into the CloudWatch log group. Something that I talked about in the last video that got corrupted is I mentioned that you can go to training.serverlessguru.com and you can go to the 0 to paid professional course, and it's free to sign up. And I would recommend that you go to that website, to our training.serverlessguru.com website, versus watching it on YouTube. You can still watch it on YouTube as well, but it's because there's going to be more structure to it. So I spent a lot of time about 6 months ago making these videos as an introduction to AWS and serverless, going through Lambda functions, DynamoDB, CloudWatch. And so if you're looking at the screen and you're like, I have no idea what's taking place, I would go to the 0 to paid professional course, watch the very beginning of it. If you want to continue and get more advanced into the course, definitely feel free. At no point are you going to be charged for anything. It's completely free. I went back and forth about, do I charge for it, do I not charge? But because AWS is developing so quickly, and I don't have the bandwidth right now to actually keep updating the course as things actively change, I may update it every couple of months, but I'm not going to update it every week or every month. So in that case, I made it free, published it out on both YouTube and on the training site, and so you can watch it on either one. If you watch it on the training site, you're going to get extra code snippets. So if there's things in those videos where you watch it and you go, okay, this is cool, but I can't see the whole code, I would recommend going to the training site. Okay. So as he clicks in here, you can see the logs that are coming out here. So you can see this first log here says info and it said records. So that's actually the event printing out. So that's important because when I talked about that scenario where I almost lost my job, it was because I had that line there. And I could then go back and look at it, and then I could review it, and I could re-loop over it, and it saved me. And then here we go, we got batches here, 258. Each batch was 25. And so you can see there that it's got 258 batches it's then going to run through. And if you look at the timestamps here, you can see how fast this is happening. So the first batch kicks off at 13:05:20, and it's still 13:05:20, and we're already up to like 25 batches. So it's going super fast. I mean, that is a for loop that's happening inside of the Lambda function. It may not be all the put requests that are actually taking place to the DynamoDB table, but it's an example there. And my cat just pushed my laptop, so I think that's the close of the video. I'll play the last bit here for you.
Large files or thousands of smaller ones. This approach loads the data quickly and reliably. With DynamoDB on-demand provisioning, you no longer have to manage write units with your table since this is handled by the service. All of this happens without needing to manage any servers, and when the traffic slows down, the services scale down automatically, so this is a perfect solution for use cases with spiky traffic. The Lambda function contains only the minimal business logic to connect the services, just over 100 lines of code in this case. This function extracts the data from JSON files, but you could easily modify the code to work with CSV or any format you prefer. Using the serverless application model, setting up a deployment package with the AWS resources in our code is also very easy. To download the examples from this video and deploy the application in your own account, visit this URL. Thanks for joining me for this walkthrough. Don't miss the other videos in this series that show other ways to use S3 to Lambda for your serverless applications. Happy coding!
Sweet. So I think that was a great video. We covered a recap of it. I didn't watch the full thing again because I didn't just want to focus on all the small details. I still probably made this into a 30-minute video. I'm not really sure at this point. But yeah, so I would recommend going to the AWS YouTube channel, watch this stuff, learn how it works. It's a really important pattern. Even working at enterprise levels, we use this type of pattern. I believe in the video that got corrupted, I even talked about the enterprise and how you can run into scaling issues. I give a small idea for what that looks like here. So when you take that file and you upload it onto S3, and it triggers that Lambda function, and then the Lambda function goes and writes stuff to DynamoDB and stores it in your database, it makes sense and it's very easy when you're doing a very small amount of interactions, right? But then if you imagine that these files weren't so small, if they were actually a lot bigger, and if you imagine that those Lambda functions took a lot longer to process, you can end up running into concurrency and scaling issues really fast. The one example of that, at a previous job, we created this system where when you upload a video onto AWS S3, it would then trigger a Lambda function, which would then take a screenshot of the video every 3 to 5 seconds in a 1 minute or 3 minute video. And so what ended up happening is that over that 1 minute, 3 minute video, we ended up getting hundreds of these invocations out of it. And these invocations then basically what would take place, it would store it back into S3. So it would take the screenshot, we get 100 screenshots, store it back in S3. That would then trigger another set of Lambda functions for every other image that got uploaded. Every single image, every single screenshot from that video that got uploaded, it would trigger another Lambda function. So while that's taking place, we upload one video, it's looping over it, creating screenshots and storing it back in S3. 1, 2, 3, all the way down 100 times. We have 100 screenshots. The video finally finishes, but let's say that first screenshot that then gets uploaded to S3, it's already triggering another Lambda function to process it while this one's still going. And that continues to happen one by one until the video finally finishes. And so it's a really cool pattern. It allows you to do a lot of really robust things, and it's obviously it's awesome. But where you can get into scaling issues is that imagine it wasn't one video. Imagine it was, this one video, let's say 200 megabytes. Imagine that we had 50 gigabytes to actually upload, 50 gigabytes, right? So then it becomes a really bad problem because now you have so much data that you need to put into S3 to then trigger these Lambda functions to process that it's actually going to overwhelm your concurrency and you're going to hit timeouts and throttles and all that stuff immediately. It can also overwhelm your database with DynamoDB if you're doing that much data and you're tracking all the progress and all those things too, because if your read and write capacity aren't set properly, that would actually happen. Now they have the pay per request with DynamoDB, so you're going to be a little bit better there. You can also, if you run into this issue with scaling, what we did is we basically integrated SQS queues throughout the entire system. We even created a Lambda puller, so we could actually pull in batches of SQS events. So we pull in like 25 or 50. We'd loop over those, pull in another 25, loop over it, pull in another 25, and we would continue to do that throughout the entire process. So with that, I'll wrap up here. This was Ryan Jones from Serverless Guru. Thanks for watching, and I'll see you next time. Bye.